Yeah, no problem. Even I was also busy in my personal work in the last week. That's why I didn't call you. So it's fine, no problem. So we can. This is the good thing. We can understand for each other. Okay. Okay. Let's start. So basically we started basic of the machine learning. I'm going to just revise all the things so that we can just yeah brush up all the things. Wait a minute. So overview of machine learning. So we can define this. Machine learning is a subset of artificial intelligence that enables system to learn pattern from data and make prediction decision without being explicitly programmed. It means, first of all, we already know that whenever we design some kind of machine learning program, so it's depend upon the data because our model learn from the data, the past data or whatever the data we put into our system, into our program. So it's learn from basically machine learning, learn from the data, whatever the data we give. Got it? I'm going to give you example, then you can understand. So just basic, yeah, basic differences. So for example, in a real life, Gmail spam filter by using this machine learning concept, we can able to build up a model which that model can trap some kind of spam email. It provides the Netflix recommendation movie based on viewing history. Whatever the history we available in our Netflix, it will suggest the movies or some songs or something whatever we watch in the past. Then stock market, it's also prediction of the stock's price. It will go down or it will go up. That can also predict by our machine learning model. That also possible. And this is the overview of how the artificial intelligence after this is a machine learning, and under this machine learning we have a deep learning. So under the deep learning we learn about the neural network. So let's see. Yeah. So these are the layers layers of our machine learning artificial intelligence. All are the part of this course: machine learning, artificial intelligence, deep learning, all the things. So deep learning automatically learn this here. What are the difference between this deep learning and machine learning? Machine learning learn from the data, the past data or whatever the data we give for the training. But deep learning automatically learn this feature from raw data like image, text or a sound. So these are the difference. Machine learning learn from the data and deep learning learn from the image. It's not like a data, simple data. It's like a image. It's learn from the image. That text we write like we write in a chat GPT. So by these things, deep learning can understand what we are going to ask from it. After that, sound. Sometimes, yeah, we use the voice to give some suggestion or ask a question from Chat GPT, or sometimes we use in a remote control. Nowadays, we just simply put a button and speak some name of the channel. It automatically activate that channel. So that's used in a deep learning. Okay. So this is the difference between deep learning and a machine learning. Okay. Type of machine learning. So we have supervised machine learning and then unsupervised machine learning. After that, reinforcement learning. There is three type of machine learning. Let's discuss one by one. So data has input and output. It means we give both the things in a supervised machine learning. We give input as well as output. So which kind of data? Let's suppose we give the past data for some student. Let's suppose we give 50 student data, 100 student data, like how they pass or fail. Let's suppose we set a parameter that if the student get 40% they pass, if some student get less than 40% they fail, and if somebody get more than 40% they also pass. So whenever we feed this kind of data, the input data as well as output data, it means we give the input, that is like marks, percentage of marks, and also what kind of result it will show. So this is called the supervised learning, where we give the input as well as output. After that, after giving this kind of data, let's suppose, let me draw a picture. Let me draw a picture, then you can understand. I'm going to create a table. Uh, just hold on. Uh, just student, I'm writing in a short form. Then marks, and then fail or pass. Pass, oblique, fail. Okay. So student 1, student 2, student 3, then 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 let's suppose 100 student, and marks like 60%, then 35%, then 80%, somebody get 90%, somebody get 40%, etc. So according to that, pass, then fail, pass, 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 like this. So this kind of data, when we fit to our machine learning program, both kind of data, input data, this kind of data, we put the percentage, and result also. When we put 60%, it pass. When we put 35%, is fail. Similarly, we give here input as well as the output. After that, after giving this kind of data, this data, entire data, our model understand whenever some candidate got 60% or 30% or 40% or 90%, it will throw the answer like pass or fail. So whenever we put some percentage of marks like 67.7, it will show either pass or fail. So this kind of data is called supervised machine learning. Hello? Yeah, got it? Okay. Now let me show you something like, okay, after that, unsupervised learning. So just read it. Data has input feature and output level. So goal, learn mapping from input and output. We have to give both kind of data. Example, predicting house price. There is so many websites these days where we can put some data like size of the room, the location, and the city. After that, it will give the price of that house on a particular place. Classifying email as a spam or not, so it will trap the spam email according to the past data, whatever the data we put. Predicting a student pass or fail. So these kinds of things our model can learn by using this supervised learning. After that, unsupervised learning. Model learn pattern from unlabeled data, no predefined output. So discover structure like cluster, groups, hidden pattern, like this. Let's suppose in this case we put only input data, but we did not give the output. Okay. So our model can predict according to the groups. Let's suppose we give some data which is similar to the another data. So our model can understand, it's create a type of groups. Okay. According to that group, it gives the answers. In this case, we only give the input but don't give any output. But our model understand the data according to the groups. They divide the all the data into the groups. All right. Yeah. So data has only input feature, no level. So customers segmentation in a market, grouping news articles. Let's suppose we give so many kind of articles, and the articles are like let's suppose on we give 10 articles which is related to chat gpt. After that we give 10 articles which is related to some news about the politics. And when again we give 10 articles which is related to the sports. So our model can group it, make into a groups, so that our model understand, okay, this is a group of AI articles, this is a group of politics articles, this is a group of game articles. According to that they will give the answer. Got it? Here we only give the data but not give the output. They can convert into the group and then give the answer. Okay, our model can understand, learn the things according to this data. After that, reinforcement learning. An agent learn by interacting with the environment and receiving rewards and penalties. For example, this kind of reinforcement learning using training a robot to walk, game AI, game AI like chess, Go, video games. So we use reinforcement learning, self-driving car, learn when accelerate, stop and turn. So here it's learn from the environment. Yeah, interact with the environment and then receive. Let's suppose somebody make a self-driving car, so that when we test the car, it's, let's suppose a breaker will come, so it's apply the brake. If not apply, it's put it affect a jerk. So according to that environmental condition, our model learn. Got it? So this is a three kind of machine learning: supervised, unsupervised, and the reinforcement. So after that, this is a picture of that supervised and supervised learning and reinforcement learning. Key concept, features: input variable used for prediction, example number of rooms, area, house price. The level, the target output variable, actual house price. Model evaluation check, okay fine. Okay, let's see. Check how will the model perform common metrics. So regression, mean square error, and square error, no, it will come later. Then classification. So we discuss about the accuracy, then precision, then recall, and the F1 score. And I think you ask a question about the F1 score, right? Yeah. So you understand, yeah, you understand about the accuracy, then precision and recall, but you don't know about the F1 score, no? Okay, let's yeah, let's discuss about this thing. Then you can understand what is F1 score. So first of all, I'm going to again repeat these things so that it will clear. Scenario: build a model to detect whether an email is spam or not. So we are going to build a model by using machine learning, so that it can trap the spam email. And so here the result after testing of 100 email: true positive 40. So spam email correctly identifies as a spam. Okay, so whenever they trap out of 100, 40 email which is correctly identified, fine. So I write it TP, true positive. After a true negative, that is 50. Not a spam email, correctly identified as not a spam. Then false positive 5. Not a spam email, wrongly marked. It's not a spam email, but our system wrongly marked that email. Then false negative. Uh, Spam email missed. Here our system is failed to trap the spam email. That is 5. The number is 5. Yeah. So I mark as a FN. So accuracy means TP plus TN by total. So TP is 40 and TN is 50. So it's a spam email correctly identified. Okay, out of 40, all email are spam. This is correct. But here out of 50, not a spam email correctly identified as not a spam. So 40 plus 50 divided by total. Sorry, not total. It's a TP, TN, FP and FN. It means sum of this. So 40 plus 50, 90, same thing, total. So 90 plus 100 is 90%. So we can measure the accuracy according to this formula. After that, precision. Precision is TP by, this is a TP, that is positive, and divided by TP plus FP. FP is not a spam email wrongly marked. It's not a actually a spam email, but our system trap as a spam. So TP is 40 divided by 40 plus 5. So it will give 88.9%. That is called precision. After that, recall. So recall is TP plus FN. FN is this one. Spam email missed. This is a spam email, but our system doesn't trap this email. It's our system failed to trap this email. So yeah, so 40 is a correctly trapped email, but 40 plus 5, that is 8.99, 88.99. So this is called recall. Now F1 score. So F1 score is 2 into precision into call divided by precision plus call. Let's understand with some example. Then we can understand what is F1 score. Fine. Let's. Okay. So F1 score. It's the harmonic mean of precision and recall. Okay, we find a precision as well as a recall. So it's a harmonic mean of precision and recall. So it balances the two. If one is much lower, the F1 will also drop. Okay, let's suppose precision is lower, the F1 also fall. If in some case recall is lower, F1 fall. So let's try to understand with the example, then we can understand. So precision equal to of all emails the system mark as a spam, how many were truly a spam. Okay, and recall of all the spam email that actually existed, how many did the system catch. And F1 score, how well the system balanced both the catching spam and avoiding mark good email. Fine. So out of 100 email, a system mark as a 20 spam. Okay. Hello. Okay. So let's suppose we have a 100 emails. So out of 100 emails, our model trap 20 email as a spam. Okay. Out of this, whatever the 20 email trap by our model, 18 are truly a spam, but 2 were actually important email and classified as a misclassified. Got it? Out of 20, 18 is truly a spam, but 2 is not a spam, but our model considered as a spam email. So there were 2 more spam email that the system missed, but 2 spam email that our system doesn't trap. Here this 2 email is wrongly trapped and this 2 email missed. Okay, got it? Fine. So precision is 18 divided by 20. This is the 18, whatever the truly email they trap, and divided by this 20, because they mark 20 as a spam email. So it will give 90% as a precision. Then recall. 18 is the correctly marked as a spam. After that, 18 plus 2. Yeah, so it gives 9.9. So here in this case, F1 score as a 0.9. This is same because both are equal. This is equal and this is also equal. So F1 is not showing any changes. But now I'm going to change the case here. But imagine it's only count 10 spam email. Okay, out of 20, they count only 10 spam email. So precision is 10 divided by 12, that is 83%. Got it? And recall is 10 divided by 20. Out of this 20, only 10 is the spam email. So 10 divided by 20, it's 50%. So there is a these two are not balanced here, but in this case it's balanced. So F1 doesn't show any kind of changes, but here there is a difference between the precision and a recall. Hello. So when I trying to find the F1, So using the same formula, this formula, 2 into precision into recall divided by precision plus recall. So whenever I find the F1, it will give 62%. 62%, but precision is very high and recall is low, and it's give, yeah, 62%. So here you see drop, okay, because it's drop. See this, it's 83%, but it's 62%. So it's drop, no. So here you see the drop. Although precision is high, our precision is high, but F1 is low. So good at identifying the correctly when it does say spam. Recall is low, missed by spam. So F1 pull the score down to reflect the misbalance. So due to this F1, we can understand the misbalance between precision and recall. That is the use of F1, and we use this formula to calculate the F1. So basically, it's F1 will help to understand the actually what is the precision and what is the recall. Yeah. So machine learning workflow, data collection. So it can collect the data from the CSV file, database, API. There is so many data source. From that data source, it can collect the data. After that, data processing, that is cleaning, removing missing data, scaling features, split data, that is training, train the model, and then testing. They can train that our model by using this data, the clean data. After that, test the model. Then trained model, apply algorithm, linear regression, and decision tree, etc. These kind of algorithm used to observe how our model work. So I'm going to explain you what is the linear regression. Then evaluate model, use metrics, accuracy, and MSME. Deploy and improve, use model in a real world application. After this procedure, we can use our model in a real world application. So let's see an example. This is an example of linear regression. I told you that after cleaning and all the process, the model will be go through this kind of applying logarithm like linear regression and decision tree. So here we are going to see an example of a linear regression. So here I think we already discussed about predicting house price in the first class. Let's again revise this. So let me show you. Okay, this is a very simple example. We develop a model and give some data and output also. So this is a supervised machine learning program. See this here, this case, first case, supervised supervised learning. So type of machine learning, supervised learning. So this is a supervised learning because we give here the input as well as the output. Let's understand the program first. So here we import a NumPy. I think you also install the NumPy libraries, right, in a Python. Hello. Yeah. So you install that. Yeah, we install it. Again, matplot, here we are going to draw graph also. That's why we import the matplot also. NumPy is used to calculate the mathematical data, and matplot is used to develop draw a graph. After that, for sklearn.linear model, import linear regression. We are going to use linear regression. In linear regression, our model is working linearly. See, let me draw a graph. So for linear regression, let's suppose we have a line like this, okay, and we have a like this, okay, this. let's suppose I'm putting here 1000, then 1500, like this, then 2000, then 2500. Okay, here let's suppose 50, after that 65, then 65, 80, then 95. So here, are you observing how the x-axis moving and how the y-axis is moving? Is there any difference? Hello? How the data is moving here? Yeah, every time it's moving 500, and in this case 15. Okay, so there is a linear changes. It's linearly changes. If I draw a graph, let's suppose this is a square foot of some house. Okay, a square foot, and this is a price of that square foot. Okay, so a person get 100 sorry 1000 square foot, they pay 50. So this is a point, and the second person want to take 1500 square foot, so he pay 6500. So this is the point. After that, somebody wants 2000 square foot and his price is like 80. Got it? Similarly, like this. So our graph is developed like this. Am I right? Here, hello. Hello. Yeah. So this is a linear graph, right? It's moving linearly. It doesn't fluctuate anywhere. It's a straight line. Got it? So this is called the, yeah, this is called the linear regression. Here, our model is trained linearly. It doesn't show any fluctuation. Okay. So same thing we are going to use in our program here. Let's now try to understand. So we import a library that is NumPy. We import a library that is a matplot. So NumPy is used to for mathematical calculation, and a matplot is used to develop a chart. This kind of chart. This kind of chart. After that, sk.learn linear model. So we are going to learn train our model linear regression here by using sklearn. We are going to develop a machine learning model which use linear regression to give some learning. So here I'm going to give some data, and this is a case of supervised learning because we are giving input data here and these things. So let's suppose somebody want to take 1000 square foot, they have to pay 50,000. Sorry, 50 lakhs. If somebody, yeah, if somebody want to buy 1500 square foot, they have to pay 65 lakhs. If somebody want to buy 2000 square foot, they have to pay 80 lakhs. Similarly, yeah, here see it's data is moving linearly because after 1000 it's 1500, that is it's moved by 500. Again it's moved by 500, so it becomes 2000. After that again it's moved by 500, it becomes 25. So each time it's moved by 500 and our price is moving by 15 lakhs every time. So it's moving linearly. It doesn't show any fluctuation. Got it? Am I concept is clear? Okay, so now model linear regression. We are going to do a linear regression because we are not giving a random data. We are giving a linear data. It's a linear data. Okay. So model equal to linear regression, model dot fit xy, prediction, that is size, whatever the size we give here, it will give prediction price equal to model dot predict. So according to this data, our model understand, okay, if somebody want 1000 square foot, they will show you the price like 50 lakhs. If somebody want 1500 square foot, our system give 65 lakhs. Similarly, whenever we give any value of the size of this our house, it will give the price. So this way our system learn this from the data, this data, and this is a linear regression, linearly. So after that, print prediction price. So this is a simple program of a Python program. Print price of the size of the square foot. After that, plot a scatter. This is for the plot a graph. Our program is finished here. Now I'm going to draw a graph also so that we can understand what is the linear regression. So plot scattered xy color blue and label actual data. Then plot xy model. So this is for basically to generate a graph. This area, okay, and using this library, matplot. Fine. So shall I run this model so that we can understand how our model is working? Okay, let's suppose I want to buy 2500 square foot. So what our model will give the answer for 2500? The price should be 95 lakhs. Let's run this program. Okay, no problem. It's taking time, but it will give answer. See, so linear graph, because it's a the movement is linear both in a square foot as well as price. So it will give a linear graph. Got it? Now, yeah, just check the answer. What is the answer? So predicted price of 25 square foot house is 95 lakhs. Is it okay? Yes, because whatever the data we give, it's um, uh, it's a trend. Our model is trend. Now let me change this size of the house. I want only 1000 square foot. Then how much it will give the answer? Our model 50, because we give the input as well as output also. Input is 1000, so it will give the 50. Just a minute. Let me run the program again. Okay, fine. Hold on. Yes. Yeah, yeah, it's also develop a graph. Okay. So, and what is the predicted price of 1000 square foot house is 50 lakhs, because we put here 50 lakhs for 1000 square foot. Now I am going to give a random number now, because our model is trend. Whenever we give data like this, it will give answer from this way, linear answer. Now I'm going to give a linear data. Let's suppose I am going to give 2200. Let's check our this machine learning program, how it will give the answer. Graph is generated. So predicted price of 2200 square foot house is 86 lakhs. Yeah, we didn't give anywhere 86. We didn't give. But according to this learning, our system understand and they calculate and give the answer. Yeah, linear regression. Yeah, here we, yes. Now it's learn from this data. It understand, our model understand how whatever the size of the house we give, it will give answer like this. But this is a linear data. It's a linear answer. Okay, so this is called the linear regression, and this is a example of this one, the supervised learning. Here we give first input and output also. Here we give input as well as output. After that, our system learn and then give the answer according to this learning. Every time they give the answer. Let's suppose I give only 500 square foot here. Where it's there is no five. Yeah, it doesn't give any 500 here, but it will calculate. Yeah, our system will calculate. Okay, just try to understand it. Okay, let's discuss one more program. Then, if you want to complete finish this class, that's fine. Right now. Okay, okay. So we can start. Okay, no problem. Day after tomorrow is fine. No problem. No problem. So just a minute. Just a minute. Just a minute. Day after tomorrow. Fine. So we have discussed this first case, that is linear regression. How, yeah, we develop a model and we trained the model and we get the answer from that model. Yes, we give 500 square foot and it's give the answer, that is 35 lakhs. We didn't, doesn't give any 500 here, but it's learned from this data, and according to this data, our system is giving the answer. Okay, so one more program is left in this topic, that is this thing, classification. So first case is linear regression. We linearly we give some answer, and second case is classification. In classification, it decide either true or false, pass or fail, like this kind of data. They give the answer. Yes. So our system will trend according to this result. Okay. We will discuss in the next class. Fine. So you want to go somewhere, no? Okay. No problem. No problem. No problem. No problem. Just just leave it. Okay. Fine then. Good night. Welcome. 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 Welcome.